not useful for most of our applications. So let's talk about how to end a while loop. Okay, so here is a new one. X equals 1, right on the top. So at this point, it says while x is less than 4, do these things. So at this point, x is equal to 1, right? So is x less than 4? Yes, so it's true. So it prints, and then it adds 1 to x, comes back, x is now equal to what? We've added 1, started out as 1, we added 1 to it, so it's equal to 2, still less than 4. So my question for you is, how many times will it print the words "it's still true"?
No, 3.
Let's find out. Okay, while x is less than 4, I'm going to make the exact same conditions. Start it as 1, move that down below because that will make a difference. Okay, that's the same code in all the significant ways. So run it. Because I say x is less than 4. When x becomes 4, it's no longer less. If I want it to print 4 times, I will say x is less than or equal to 4, and then it will print that 4th time. So that's something to pay attention to, is whether we're using less than or equal to in those loops. There's another way to end a loop that's a little bit different, and it is to use the break statement. Anytime we have a break statement and this gets run, it will break out of whatever loop I'm in. If I have a loop inside a loop, it'll just break out of the innermost loop. This code is similar, right? We've got x equals 1. We've got an increment. It's printing something. And I'm checking to see, is x equal to 4? Then break. So I have an if inside my loop, even though it says while true on here, right? So we're back to while true. So it'll go forever, right? Verified. And then if I say if x equals 4, then I break. Okay, so a few things I want to point out about this code before I run it. The first thing is that I'm using equal to 4, which means it's going to stop at 4. That's a nice way, rather than saying less than and confusing myself. If I just say when it gets to 4, just stop. Now, when this gets done, it will exit that loop immediately. If there's code in here after that, it will not be run. I want to show you. Print. This is printed after break. Okay. So when it hits this break, this will not get printed. And that impacts things. The other thing that I want to point out, and I want you to pay attention to this because this is going to start becoming very relevant to you. Notice, I have my block of code that's part of the while loop. It's indented. I have an if statement that's part of that. The block of code that belongs to if, which is just this break, is indented one more step. So every time you have a branching structure or a loop inside a loop or inside another branching structure, you indent again. So you want to pay attention to the indentations here. So let's run this. Okay. So a few interesting things. It didn't stop at 4, did it? Why didn't it print the fourth one? Let's look at the code structure here, right? And it prints the fourth, it stops at 4 because when x is equal to 3, it says, okay, we're going to go through. It prints, it becomes 4 and immediately stops. So it doesn't print anything once it's 4. So you always want to think about where you put your increment operators versus your code that you want to be executed when you're trying to stop your program. If I take this down to here and I run that, and just by moving that one line, now I have 4. But notice, the line that says this is printed after break is never printed because it's after the break on that last one. So whether things happen in one order versus another determines how that code is run. And it's going to take a little bit of logic and a little bit of sometimes just playing around, right? You know, I'm a huge advocate for just messing around and finding out. Okay, so that's how we do things in programming a lot of the time. If you want to sound smart, you say I'm using the scientific method. Those are the exact same things, people. Science is tricking you into thinking that science is hard when it's really just messing around and finding out. Times a million sometimes, but
Science is always